Assalamu alaikum dear students. Today we are going to discuss another conic section which is ellipse. So firstly we'll define what is ellipse. An ellipse is a set of all points in plane the sum of whose distances from two fixed points in the plane is constant. Here two fixed points are called as the foci, that is plural of focal point, that is focus. Now if we consider the point P1 such that it is sum of the distances from two fixed points, that is P1 F1 plus P1 F2 equals to, if we consider another point, say for example P2, in such a way that is P2 F2 plus P2 F1 equals to constant, then we say that these 2 points are on the ellipse. So this means that each and every point on this ellipse satisfies this very equation, that is the sum of all those points, the sum of distances of all those points from a fixed 2 points is always constant. Here this constant distances of these points is always greater than the distance between these two foci, that is these two fixed points. The midpoint of the line segment, that is F1 F2, is called as the center of ellipse. The line segment joining the foci is called as the major axis of this ellipse, while as the line segment perpendicular to this major axis and passing through the center is called as the minor axis. So this means that here the major axis is AB because it passes through these two fixed points, that is it passes through the foci, while as the minor axis is CD because it is perpendicular to major axis and it passes through the center of this ellipse. Usually we denote the length of this major axis, that is AB, equals to twice A, and we take the length of the semi minor axis as 2B, while as the distance between the two foci, that is F1 F2, is twice C. That is, if we have an ellipse with these features, then A dash A is the major axis, its length is 2A. When its length is 2A, this means that the coordinates of the endpoints of this major axis are A0 and minus A0. These endpoints of major axis are called as the vertices of ellipse. Similarly, if the minor axis is of length 2B, then its endpoints are 0B and 0 minus B. 0B and 0 minus B. Here its center is 0, that is its center is O, its coordinates are 0, 0. Now OA equals to OA dash. Length of OA is positive A, while as the length of this OA dash is also A, but its direction is negative. So here this OA is called as the this major axis, and its length is simply A because length of the major axis is 2A, which implies that the major length of the semi-major axis is A. Similarly, length of here the minor axis is which is B dash is 2B, which implies that the endpoints of this minor axis are 0B and 0 minus B. Hence its length, that is OB, which is the length of semi minor axis, is B. So now we will derive a relationship between this semi major axis and the semi minor axis, and the length and the distance between the two foci. That is, here distance is 2C between F1 and F2, which implies that the coordinates of this foci are C0 and minus C0. Now when we draw a triangle, here this is the ellipse, F1 and F2 are the foci, B is the point on this. So when we join this, we get a triangle, right angle triangle BOF1 or BOF2. Here OA OF1 equals to C, OB equals to B because it is semi-minor axis, and OP equals to A because it is semi-major axis. Now clearly in right angle triangle, by Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square, which is C square plus B square. This means that F1B square equals to root of B square plus C square. Similarly, F2B equals to root of B square plus C square because distances are same with opposite signs. Now if we consider a point, that is here point P, then by definition Pf1 plus Pf2 equals to, now here this Pf2 can be written as F2O plus OP. Now F2O equals to minus C, OP equals to A, and this here this Pf1, this Pf1 can be written as A minus C, that is A minus C. Similarly, Pf2 can be written as C plus A, hence overall distance, that is sum of the distances of this point from two fixed points, is simply 2A. Now let B be the another point. Let's assume that B is this point. Then by definition, Bf1 plus Bf2 equals to root of B square plus B square plus root of B square plus C square. That is simply twice root B square plus C square. Now here B lies on ellipse, P lies on ellipse. Then by definition, sum of the distance of these two points from two fixed points is constant and is same, which implies that this 2A equals to twice root B square plus C square. That is twice A equals to twice root B square plus C square, or A equals to root of B square plus C square, or squaring, that is A square equals to B square plus C square, or we can simply write C equals to root of A square minus B square. Here this C is defined because A is always greater than B, because A is the length of the semi-major axis, B is the length of semi-minor axis. This semi-major axis or the major axis is always greater than, its length is always greater than the length of minor axis. That is why here this C is defined, because this quantity within the root is positive. Now we will discuss the special cases. Now if C is 0, this means that the distance between the center, where C is the distance of one focal point from the center, if it is 0, this means that the two foci, that is F1 and F2, will merge or will coincide with the center. Hence simply when C is 0, major axis equals to the minor axis, we get simply a circle. So circle is the special case of ellipse. Now if C is A, this means that the distance end point of that is the vertices or the end points of major axis, or actually the foci, and B equals to 0. When it happens, it simply means that we will get a straight line. So straight line is also the special case of ellipse. So inshallah in tomorrow's video lecture we will discuss the eccentricity of the ellipse, and we will derive the standard form of this ellipse. So thank you.